All right, so good day everyone. So welcome back for the another video that we're going to have for this day, because we're going to have the new discussion for a new topic, which is connected for the previous one. All right, so um, before we start, as usual, let's have our opening prayer first. Okay, so let us pray. So, in the name of the Father, the Son, the Holy Spirit, Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and safe today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, the Holy Spirit. Amen. Alright, so once again, good day, and I'm glad that you are here once again for the continuation and for the topic that I've mentioned from the last video that we've posted. No, so this topic that we're going to deal is connected for the whole series of the world of geometry, no? So last time we already tackled, about the topic of the circumference of the circle, no, and the area of a circle. So when we are finding the circumference of a circle, basically we are finding the perimeter or the measurement outside of the circle itself. Okay po? So the measurement outside of the circle itself or the line itself that make it as a circle, no? In a plane figure, okay? All right. So how about for the area of a circle? So this was the recently, no? Recent one that was posted before this video, no? Which we are telling when we are talking about area, no? What is area once again? So when we are talking about area, so I'm not presenting it, no? So when we are talking about area, it is the measurement of the size, no, of the flat surface in the two-dimensional or in a plane. Again, when we are talking about the area, no, we are referring to a two-dimensional figure. Okay, we have these dimensions. What are the dimensions? We have the vertical and the horizontal. Correct? So in that means we are referring in 2D figures or in a plane figure. Okay. So with that said, we already we were able to deal in the 2D figures. Okay. So by this time we're going to deal in a solid figure or the the 3D figure already, no? So but before we deal in the 3D figure, let's have a recall. Recall with regards to the formula when we are dealing with circumference area of this circle. Okay, so uh, along with that, we're going to show already the formula for the volumes as well. Okay, so uh, in order for us to have it already, so let's try to recall what is the formula of the circumference of the circle. Of course, we have the givens of radius, correct? We have the radius. Sometimes we also have the diameter. So this is for the circumference, okay? Circumference. All right. So how about for the area? When we are dealing in area, we also have the radius, also the diameter, correct? But when we are dealing in formula of circumference, there is a formula for radius and there is a formula for diameter. But when we are dealing in the area of the circle, we only have the formula which shows the radius. Okay po, we cannot use pi d squared. That's incorrect. That is wrong. Okay, so with uh, these two things in circles, we have this circumference and we have this area, no? We have one common thing that we have in the formula itself, and that is the pi, right? The pi. So when we are dealing in pi already, no? When we are dealing in pi, it has the value or the approximate value that we standardize into a round of places, no, nearest to the hundredths place value of your decimal points, which is 3.14. Okay po? Or 3.14 hundredths. Okay? So that is the one. So in order for you to visualize or to recall once again, so in circumference, now we have this pi, which is 3.14, as well as for the circle, no? For the area of the circle. So in circumference of the circle, we have this formula when the given is diameter. Okay, we use this formula when we have diameter. But when we have, no, when we have the given which shows the radius only, we have this formula. Correct? But what I've said last time, if you're going to have the exam or whatsoever test results, what I suggest, no, or what I recommend for you to use is this one, the 2 pi r. It would be much better. It would be much better. Okay? But it's not wrong to use the pi d, because pi d is also correct. Okay, po, it's just that it would be we could have the standard that 2 pi r would be the formula for the circumference of the circle. Alright, so next in line is the area of the circle, and the formula of that one is pi r squared. And when we have the pi r squared, no, we already um, we already talked about that the formula of the pi r squared would be similar, no? Has a similarities between the circumference, because the givens inside the formulas of the area is similarly found in the formula of the circumference, because we also have the radius itself, right? So we have the radius in the pi. The only matters in circumference is that we need to multiply the pi r. This is the technique, that's why I am choosing this formula. The reason why I am choosing that formula, because I have a technique in order for you to remember. What I'm doing is to remember this pi r always. So when I remember this pi r, we are dealing in circles. Now, in pi r, when we are finding circumference, you just need to multiply that pi r by 2. Okay? Now, when we are when we are finding the area of the circle, you need to square the r. Only that one. That is the technique already, all right? So, with that said, we are already done in circumference of a circle and the area of a circle with the formula that was given. No? So, by this time, we're going to deal with the volume, which you can see I have the formula for the cube, which is E cube. No? So, when you see an exponent that is raised to 3, that is called as cube. Again, for exponent which is raised to 2, we call it as square unit. Again, square unit. We already discussed why it was mentioned that it was a square unit, because in every shape that we tend to seek how many square do we have in every shapes, no? Or how many units of squares that you can have. But when we are dealing in an exponent of 3, no, we call it as cube. Why? So later on, we're going to discuss that one. So once we have this formula for the cube, or the formula of the uh, volume, no, we tend to have also the formula for your rectangular prism. Now, I'm going to show you already later on what are the prisms that we might encounter in terms of volume. We have this rectangular prism, the cube itself, and the triangular prisms. Alright, so there's a lot more in terms of the volume. So let's have it already. So for this lesson number 5, we have volume. So before we deal in the definition of volume, we go back. Let's go back first in the area. So when we are dealing area, what is the area once again? When we say area, that is the measurement of the size of a flat surface in a two-dimensional plane. Again, the measurement of the size of the flat surface. We tend to say it flat surface because we are depending on a two-dimensional figure. Okay, that's why we are in flat surface. But okay, when we say volume, it is different already. We are not trying to find the measurement of the size, of a flat surface, or the areas inside of a flat surface. We're not aiming to find that one. Thus, we are referring, when we say volume, we are referring for the capacity. Okay, so when we say volume, when someone asks you what is a volume, you could also say that volume is also known as a capacity of a 3D figure. Okay po. So also, it is the amount of space. So from the word space, we talk about the space figures that you could find everything around you. Again, you. From the word you as a person, you are in a 3D figure, but most likely in a lot of figures, because of course you have sides, you have identical figures in your left parts, right parts. Also, you are surrounded by a space. Okay? I want you to always remember that one, that you are surrounded with a space and also a 3D form figures. Whether you are lying around, whether you're sitting around, you are in touch of space and space figures. Alright? So also, when we are dealing in volume, we have three-dimensional. So, what is that one, Sir Jai? What is the three-dimensional? When we have vertical line, isn't it that in area we are dealing in two-dimensional line? So, we have this vertical line and we have the horizontal line. Okay po, horizontal line. So, what is the third dimensional? Is it the diagonal line, Sir Jai? Is it the diagonal line? Well, basically, it might end up into a diagonal line, but it has a different state. So when you are dealing in the third dimensional, you could just refer into some examples in real life. For example, for those who are playing games, for example, who knows the games of, let's just say, Pac-Man. Who among you were able to experience of playing the game of Pac-Man in a console, right? So most of the times you're playing the console with a joystick, correct? With the buttons, wherein you need to do something else, right? Also in Mario, correct? In Mario, in Contra, or in those things which is in 2D, you can see some pixels. Okay? So those are examples of 2D figures. And whenever, for example, if you will see a character will be facing in the right side, it is just simple as pixels, or flat figures that you can see that they are facing the right side. But when they are facing the left side or the other side around, you cannot just simply see that they are really facing, or the moment that they turn their body, not, but they just switch figures, or switch places based on what direction that they are going to face, no? But when we have three dimensions already, no, we tend, no, because if you based on an example of a game, no, when you have 2D figures, your character, what your character can do is to move vertically. This is vertically, vertically and horizontally, vertically and horizontally. And what is that vertical? Your character could go upwards or downwards, or jump upwards or jump lower downwards, okay, or fly upwards or fly downwards, or you could go right side or left side, right? So that is uh the motions of directions wherein your character could go, right? Either it's a Pokemon or a Battle Bros based on uh, a 2D, no? In your Game Boys, no? Those are 2D figure examples. Now, when we are dealing interdimensional, no? If this is a square, your character cannot just simply go in the left side and right side and upwards and downwards, but also you can your character could go with you and towards you and goes beyond in your screen. So if this is a square, for example, if this is a square, this is simple. For example, I'm going to have an example, so that you will not have a confusion with this matter. So if this is my example, for example, if this is Mario, for example, this is a Mario. I know it might look like a mini. It might look like a uh, random stuff, no? Let's just say this is a Minecraft, and this is my character. He can go upwards, downwards, no, right side, left side, correct. But if that character of mine, I make it in 3D form already, no, I could just put him a square box, right? So that is my character. If that is my character already, now basically what I could do is to give it some figures of it, because it is in 3D form already, correct? That is in 3D form already. Now let's just say that is the one. Okay. So what I'm saying is that when you have 3D figures, you are dealing not sides, but this is what we call as edge. Because if you are in 2D, what you could see is only figure what's in front and what's in the back part, right? So we could, what you could see only is the sides. Okay po, the sides. But when you are in 3D figure already, you are referring to the edge. This is the edge. This is the edge. Okay, this is the edge in every figure, so that it will be formed as a molded person, no, that you use to visualize. It should contain an edge. Okay po? That's why in terms of volume, we are referring for the formula of E. And E stands for edge. Okay po? So what is that third dimensional? So basically in terms of Cartesian plane, we have this X and Y. That's the one that I've mentioned in the video in area of a circle. So if you're wondering what's that around, you may check that information to the previous uh, video. Now, which is the area. Now, if you have this x axis and when you have the y axis, okay, all right. So once you have the x axis and y axis, we have what we called as z axis. This z axis, no, this z-axis deals with the edges or the other way around of your figure. So it would form into different uh, formalities that if you could visualize a square, it will not just be a square, but it will become a solid figure, which we know that it is a cube. So telling, as we said, solids, no? So let's define what is a solid. So when we have solids, it is measured in cubic centimeters. Again, when we say cubic, from the word cube, cube is in a solid form state of a square. Again, from the square itself, this is a 2D, correct? That is a 2D. So if we are going to find the area, we could simply have the square unit, right? But when we are dealing in volume, we are dealing in cubic centimeters or cubic itself. Okay, cube. So when we say cube, it refers to the edges of that square, which it contains, no? It contains edges already that forms, it has six faces, right? So I know you know what is the figure of a box, no? So that's an example of a cube. So also, when we say cubic centimeters, it could be abbreviated for the form of cc or cm cube. Why? Oh, maybe you're going to ask me, sir, why can't we just simply put as cc or cubic centimeter and not cm raised to 3 or the third power? Now, what we could do is to base on this centimeters cube in order for us to know what is the unit. Either it's centimeter or meters. Okay, so later we're going to talk about that unit. So, for example, if an object is 3 cubic centimeters, you would write it in 3 cc or 3 cm cube. Okay po? But basically, we're going to recommend to put this in this format, no? So wherein your exponent should be raised into 3. Okay? So, as I mentioned a while ago, maybe you're going to ask me, why is it CC and CM? This is an example of a cube. Okay, from the cubic meters or from the word cube. As I mentioned, in area we are finding the square unit, the unit itself, and the square, right? So we are referring for the square, but in this volume we are referring for the cube. Okay, so why is it cube, Sir Jai? Because in square we are referring to the two dimensional, which is the horizontal and the vertical, or the x-axis and the y-axis. So, as I mentioned, we also have this what we called as, or this is the x-axis, or this could be x-axis, or what we called as the z-axis. This is the z-axis, okay? Or this could be the z-axis. This line is the z-axis or the third dimensional that forms a square as a cube. Okay, so it seems like it it grows in a certain manner that it has a equal side. For example, this is a square and it is a square as well that has the same value of this square. It's just that if you have this length and width, now for example, if you have this length and width, and you also have length and width, what you had is you have this third dimensional that connects these two figures. Okay, did you imagine it already? This is the third figure or the third dimensional which forms it as a cube or a 3D, and this is what we called as the z-axis. Okay, so there will be some differences in terms of calling, which is the length, which is the height, which is the width. Okay, so volumes measures in 3D. Again, area in 2D, volumes measures in 3D. and it measures in cubes. All right, so before we deal in terms of uh, formulations, I would like to go back in this unit. So when we say units, we are referring. So this is the basics, no basics units that we could see in some examples in our real life scenarios. So if you have a ruler right now, you could get your ruler and try to look in your ruler. There is three kinds of units inside of that one. So we have this inches, no? This is our inches. Okay, so in every lines that you could see in here, this is inches. So this is 1 inches. Okay, again, this is 1 inches. Okay, this measurement is 1 inches. Another measurement is an inch. This is an inch. Okay, so what I'm telling is you could see an inch in the side of a ruler, but also you could also see, no, you could also see another kind of measurement, which is in centimeters. What is in centimeters? This is the centimeters. Okay, these numbers, which is in a little bit contact, this is centimeters. Are we clear? And this mm refers to the smaller lines that you could see between the numbers in your centimeters, and that is what we call as millimeters. All right, so to further view it in a narrow view, no, we have this example. Millimeters are the lines that you can see between numbers in your centimeters. Okay, so this one line contains 1 millimeter, and this one numbers, or the range of one numbers, is that is what we call as 1 centimeter. Okay, so this range is 1 centimeter, the second centimeter, the third centimeter. Okay, so in terms of conversion, in 1 centimeter, you have 10 millimeters because there are 10 lines. 1, 2, 3, 4, 5. This is 5. 6, 7, 8, 9, and 10. Okay? So in 1 centimeter, you have 10 millimeters. Alright? Okay. So just like an example, if you're going to measure a pencil, no? If you measure the pencil, we could have 75 millimeters or 7.5 centimeters. All right? So that's an example. So let's deal with this one already. So let's deal in cube. So in terms of cube, we have a formula. A formula which we might uh, be interested in terms of finding this one, because what we need to find is the edge only. Now, in terms of edge, there is only one specific value for your volume. Why? Because when we say cube, it deals in square, correct? And when it deals in square, it deals with, for example, this is a perfect square. Now, let's just say that both of them are in perfect square. For example, this is square, this is square, for example, no? And they share the same value. And when we say square, all sides are equal. So, for example, this is 4. Of course, this is 4 as well. So, when we are dealing in uh, volume, we tend to set the same measurements of your shape, of whatever your shape is. So what is your shape? Your square is in 4, no? 4 measurements that has the same values, no? So therefore, that square at the back part contains 4 units as well in each side. So therefore, in each side as well contains the same amount of value. So what I'm telling is that what you will be doing is to get the edge only, because it only has one kind, or one specific value for every edge that it contains. Okay, so basically the formula, no, the formula of that one is volume, or V, is equal to E cube. Okay po? So in terms of cube or a cube, what you need to do is to find how many, no, cube can you fit inside a cube. Okay? How many cube can you fit inside a cube? Okay. So you're going to find how many cubes you can put inside a big box. You just imagine that is a big box. Okay, you just imagine that is a big box. Oh. Then inside a big box, you can just imagine how many Rubik's cube can you fit inside that big box. So that is what volume is all about. The capacity inside a big box. How many Rubik's Cube can you fit inside the big box? Or how much is the capacity that big box can contain Rubik's Cube? That's the most realistic example, no? So, in order for us to be guided how to solve this one, no? So let's try to a little bit example, no? For in finding the volume of this cube. Okay, so reasoning that we are in cube, let's deal with cube. So let's just say that your cube contains 4 centimeters in each side. Knowing that it is a cube, once again we are referring in three-dimensional lines. So we are referring for the horizontal, vertical, and the other dimensional. So what we tend to use in this part is in your area, isn't it? That in your area, in your rectangle, we have this what we call as length and width. Okay, length refers to the length of or the measurement how long, no? How long is your uh how long is your object or your shape is, correct? And what is the width? When we say width, how wide is that object or that figure? And when we say height, how tall is that figure? All about starting from the bottom up until to the top. So basically, if we're going to deal in area only, we just simply have length times width, correct? So how long is your object or how long is your figure, and what is the wide? How wide is your figure? Okay, so that is all about like length times width. But when we are dealing in terms of volume already, we have this height, no? Though it is a cube that we know that in every side it contains, no? It contains the same value, exact value in every edges. So what we could do is still deal in the three dimensions. So first is the 4 centimeter. This is the length, and this is the width, and this is the height. So length is the how long is your object, and when we say width, how wide is your object, and when we say height, how tall is your object, starting from the bottom up until to the top. All right, so from the formula itself, we have the formula of V is equal to E cube. Okay po, again, V is equal to E cube. When you say E, that is the edge. Okay? Edge raised to 3 or cube. Okay? So basically, what we're going to do is, how do we deal in problem solving? First is to put your given. So, what is your given? What is your edge? So, if you will notice, in terms of cube, all edge are equal. So basically, what we're going to do is to put the volume, the edge, which is 4 centimeters. Okay. So with that said, is that the only one that we need to find? Yes, because it's in cube. Okay. So basically, what we're going to do is to simply what? We're going to simply substitute the value of your E to your formula. Alright, so with that said, your E will replace by 4 centimeters. So in that case, it will become 4 cube. Okay, or you could just simply put it in this way. 4 centimeter cube. Possible that one, ha? Possible that one. Okay. Or maybe you could just simply put 4 then cube. Possible as well. Okay? So, when we are dealing in terms of exponents, this is your base and this is your power, correct? This is your exponent. So, in terms of exponents, what is exponent all about? I did mention that one. What is the exponent all about? What is an exponent? Sige nga po. when we are telling what is an exponent, exponent tells us, no, like how many times would be the how many times would the base will be multiplied to itself. Again, how many times would the base will be multiplied by itself? Or what's your base? The base is 4. Okay, so you're going to write 4. But how many times are you going to multiply the 4 to itself? Okay, it's 3. So it shows, the exponent shows how many times. So you're going to multiply the 4 3 times. Okay, so by itself. Okay, you need to multiply 4 times 4 times 4. So we know that 4 times 4 is 16. And you still have 4. And we know that when you multiply 16 by 4, oh, let's try now. 16 multiplied by 4, 16. 6 times 4, the answer is 24. 4 times 1, the answer is 4. Plus 2, that is 6. That's why you have 64. Once you have the final answer, which is 64, don't forget the unit, then the cube. Okay, this is not unit squared, because we are in volume. That's why you need to put the unit and the cube. Okay, all right. So another example. Let's try to have another example. So first in line, what should you do? You should do is to put the given. What's your given? This is a cube, no? So you need to put the 2.5. Alright, 2.5 what? Let's just say it's meter. It's in meter. E is equal to 2.5 meter. And what's your formula? The formula is V is equal to E cube. Alright, so if it's E cube already, no, what you're going to do next is to substitute the value of your E, or replace, no, to your formula. And your E will be written as 2.5 instead of writing it as 2.5 raised to 3. Better this one now. So in that case, what you could do next is to solve how many, no? What will be the value when you find the cube of 2.5? So it seems like 2.5 multiplied by 2.5 multiplied by 2.5. So 2.5 times 2.5, that is 2.5 times 2.5. 5 times 5, that's 25. 2 times 5, that's 10, plus 2, it's 12. So 2.5, that is simple as 2 times 5, that's 10, carry 1. 2 times 2, that's 4, plus 1, that's 5. That's why when we add this, we could have simple as 5 plus 1, that should be 6. 6. Let's erase this first now. Instead of putting 5, let's put it as 6 to 5. Is that 6 to 5 already? Not. Because you're going to ask yourself, how many decimal points do you have? How many decimal points? You have 2 decimal places. So you're going to put 2 decimal places. 1, 2. Decimal point will be located in there. Now, is that the final answer already? Not yet, because what you did is to multiply these two terms already. But you still have this last 2.5. We're going to multiply it by 2.5. What is the product when you multiply 6.25 by 2.5? Let's try. 5 times 5, the answer is, let's just simply copy, because we know that 25 multiplied by 25, that is simple as 625, no? But my number one technique is to simply copy first the first part, that is 125, no? 5 times 5, that is 25. 5 times 2, that is 10, plus 2, that is 12. Carry 1. So 5 times 6, that is 30, plus 1, that is 31. So how about for 2? What you're going to do is to multiply still. 5 times 2, the answer is 10. Carry 1. 2 times 2, the answer is 4, plus 1, that is 5. 2 times 6, the answer is 12. So in that case, what you could do is simply add it already. So 5 times nothing, 5 plus nothing, you just put 5. 2 plus 0, that is 2. 1 plus 5, the answer is 6. 3 plus 2, the answer is 5. And 1, bring down 1. What I did is to simply turn it out in here, huh? Because we don't have space anymore. So, would this be our final answer already? What do you think? Not yet, of course, because we need to find how many decimal places you had, no, when multiplying those two. You have three decimal places. So what you're going to do is to put three decimal places in that final answer. So your decimal point will be placed in there. Now, so it will become 15.625 thousandths. Okay po, or 15.625. Okay? So, if it's three decimal places already, no, what I will be requiring, no, to you, what I will be requiring to you is to round off into two decimal places. So that will be our standard, no? Our standard will be whatever your final answer. Listen ha, whatever our final answer is, you need to round off that final answer into the nearest two decimal places or to the nearest hundredths. You need to round off the final answer into two decimal places. So what is the rounded value of this 15.625? The final answer is 15.63. Oh, this is the second place value, second decimal place value, right? So you're going to round off that one and you need to depend on the right value, which is 5. You know that 5 is in the range of 5 upwards. So when the number is 5 upwards, you need to add 1 to the rounded place value. And that 2 will become 3. This is your final answer. Is that all? Of course, you need to put the unit. What's your unit? That is meter cube. Gets already? Alright. So I hope that it was clear. Now, so let's deal already in terms of rectangular prism. So this will be quick already. Now, so when we are dealing in volume, no, in rectangular prism, no, it is just the same in terms of cube, no? But this is where the terms, which is the length, width, and height, will go in our topic already. No? So, based from the definition, a three-dimensional solid that has two congruent and parallel faces that are rectangle, the remaining faces are rectangle. So, for example, no, when you have this one as the rectangle, okay, and the rectangle itself, this is the one. Okay, these are the parallel rectangle, you know. These are the parallel faces of your rectangles. Now, the only concerns that you might have is that if this is parallel already, no? If this is parallel already, the only concerns that you have is the connectors. Right? This is the connectors or the width, no? The length that you have in your rectangle is the length or how long it is, the height or the width at the first place, because if this is your rectangle, this is the length and this is the width, correct? So your width was converted in height format. So if you will notice, this height is the width at the first place. So your width will be turning out as the wide or the wide format of your shape itself. So basically, the faces that you will be forming, no, you will be forming is in a format of rectangle as well, in a way that your faces will be in four sides. And what are those sides? I'm going to erase ha. Uh, if this is the way how you represented your rectangle first, this will be your first side and this will be your second side as well. Okay, so there will be parallel rectangles as well, or maybe it might be long or it might be not. Okay po, based on what is the longer, which is the length, and which is the width, or which is the height, what that was enlarged or minimized into a small part of the volume. Okay, so let's deal already in the other definition of this volume in terms of rectangular prism. No, so the cube is a special kind of rectangular prism. So basically, we tend to say that rectangular is based on a cube. Oh, well, yes, no, but in terms of rectangular, no, it only denotes that one side of a square is much longer than the other side. So that is where the rectangle came from. So therefore, that the edge of this cube, no, doesn't have the same amount of the other edges. Okay po? Because it represents that we have three different edges in this rectangular prism, which are the length, width, and the height. So these are the three edges. I want you to remember that this rectangular prism, no, contains three different edges: the length, width, and the height. Okay, so when we are finding the volume or the formula of the volume for the rectangular prism, the volume would be length times width times height. Only that one. We're going to multiply the length, width, and height. All right. So let's try it out already for an example. No, so this first example. Okay. So you have, what is your given? If you will see, you have length. What is your length? Your length is, what do you think? Your length is, of course, 5. And your width is 2 and your height is 6. When we say length, even though 6 is much greater by 5, no? If you will notice, the length of your figure is smaller than the height of that figure. Because if you're going to refer to how long is your figure, this just simple as 5. No, it is just not that long, but it might be small, no, because we have 5 cubes, no. Again, that is contained of cubes, no. 5 cubes. How many cubes? 1, 2, 3, 4, 5. 5 cubes only. So how wide is your total figure? How wide? How many cubes can you see? How many cubes? There are 2 cubes only. This cube and this cube, right? 1, 2. So your cube is 2. Your wide is 2. So in the last portion, this is not just simple as b is equal to length times width times height, no? But what uh, we tend to do is to find also the height itself. When we say height, how tall is your figure? So how many cube can you see that was formed in order for us to tell how high is your figure? We have 1 cube, 2 cube, 3 cube, 4, 5, and 6 cube. How many cubes? You have 6 cubes. So when we are going to find the volume of that figure, of this figure, no, this whole figure, how do we deal with that one? We need to multiply the length, the width, and the height. So basically, we're going to multiply them, and once we could have 60 cubic units. Okay po? Cubic units. So 5 times 2, that is simple as 10. And 10 times 6, 10 times 6 is 60. That's already good. So, how about this one? So, if you'll notice, in this figure, how many cube can you see for its length? The length is 4 cubes because there are 4 cubes. So, what is the, how wide is your figure? How many wides? 1, 2. How many cubes? 2 cubes. So, therefore, your width is 2. So, how high or how tall is your figure? There are 4 cubes. That's why your height is 4. So basically, what from the formula goes with volume is equals to length times width times height. Correct? So basically, you're going to multiply 4 times 2, that is 8. And 8 times 4 is 32. So therefore, the total volume of this figure is 32 cubic units. Gets already? Alright. Next, there's a lot of examples, no? So for this example, this just similar for the others. So let's have this figure. So how many cubes can you see of how long would this figure be? So how many cubes? There are 1, 2, 3, 4, 5 cubes. So there are 5 cube units. So that is your length. How would be your width or breadth? This is in another term, but we use this in width. Okay po, width. Okay. So your width is how many? How wide is your figure? How many cubes? There are 2 cubes in your figure. So you have 2. Okay po, 2. So later I'm going to tell why is it 3, no? So how about for your height? Your height is 3 cubes already. Okay po, this is 3. Sir Jai, why is that? The width was represented as 3 and your height was represented into 2. Why is that so? So in terms of rectangular prism, what I mentioned last time, no, it might vary whether what is the greater one, whether the width is the width contains much greater value compared to length, or height might might be greater than length, no, or vice versa to the other parts. It's just that if this is your figure, it might vary as well whether the figure is standing in that figure. For example, no, I'm going to draw a figure of, let's just say this is a figure. Okay, this is a figure, ha. This is the figure. That's the drawing in that figure. So that whole figure, this whole figure is standing in that format. Now, what if that figure was standard, no? Wherein the picture that was imprinted into that figure was in this format already. See? So it was tilted rotationally into this format, correct? It was rotated in a counterclockwise form, correct? So it might vary whether what would be the width, what would be the length, or what would be the height, as long as you have these three, no, 3 dimensions, and when you multiply them, you will end up in one final answer. All right, so once we have 5 times 3, that is 15. And when you multiplied it by 2, that is 30. Oh, let's try. 5 times 2, that is 10. And when you multiplied it by 3, the final answer is 30. So basically, you have 30 cubic units. Okay, so this one, let's deal with this one. So let's try this example, which contains as well, no? Which contains values, and later we're going to try as well wherein one of the part is missing and what to do. Okay, because maybe you are used to find such values which can't be found, no, which can't be found in a certain manner or in a certain problem. For example, let's have this one. What are your given values? Or which is your length? The length is 3 centimeters. This is your length. Sir Jayo, I thought that 3 centimeters was the width. I thought this was the length. So I guess that the length should be 12 centimeters. And your height should be 4 centimeters. Oh, that is correct. Your height is 4 centimeters. Why is your length, which is supposed to be 12 and 3, was placed in different format? Why did you, what do you think? What do you think? Hmm. Do you think what? What is the reason why is it like that? Do you think of something? Hmm. Because what? If you will notice, this is your length. That is the 3 centimeter. Okay. So your width is this one. This is the 12 centimeter. Okay po? And how tall is your figure? And this is the 4 centimeter. Okay? So your figure was formed into this format. Okay? So it's just that it's in the matter of how was it stand or how was it placed, no? So your length would be your 3 centimeters, 12 centimeters, 4 centimeters. So final answer, if you're going to multiply them all, so if you're going to try, no, 12 times 3, the answer is, what's 12 times 3? That is 36. 12 times 3 or 3 times 12, the answer is 36. Times 4, and the answer is what? Of course, there's the answer already, no? So the final answer is 144. So don't forget the unit. What's the unit? Oh, from the given. The given is centimeter. Don't forget the exponent, ha. Again, cube, ha. If the cube was not there, I will consider it wrong. And it is considered as wrong. No? If you don't have unit, it is considered as wrong. Okay? So, next. How about this one? So, your length was 7. So, this is your length. This is 7, no? This is 7. Your width was 10 centimeters. Your width is the wide. How wide is your figure? So this is your 10. Okay? And how tall is your figure? So let's just say that this is your figure. Okay? Alright, so this is 5. So this is your figure. That's already length, width, height. That's already. So it's a matter how your figure was placed. Alright, so your length was 7 centimeters, your width was 10 centimeters, height is 5 centimeters. So if we're going to multiply 7 times 10, the answer is 70. And when you multiply it by 5, 70 multiplied by 5, how is it? It would be 350. Why is it so? The technique when you are multiplying by tens or hundreds, isn't it? That what I've mentioned is to no? Put 0 already in your final answer. But if you have different answer, for example, instead of, for example, when you have 10 times 5, automatically your 5 will have 10 on its end, right? Because what happens is that 5 multiplied by 1 is simple as 5. That's why you have the first 0, which is this one, and you multiplied the 5 by 1. That's why you have 5. But what if the 1 contains a number which is 7? 7 already. Then you multiply the 5 by 7. 7 times 5, that is 35. Okay? So the technique is that you count how many zero, you input the zeros, then multiply 5 to the number of your tens or your hundreds. So that's in that case you can have 35. Right? So in other words, your final answer is 350 centimeters. Again, your unit is centimeter, and don't forget to put the cube. Now, you're going to ask me, sir, what should be the standard or the format that we're going to use or going to put in the final answer in our exam or whatsoever, no? Is it the centimeters cube or the cc? It is recommendable that you need to put the unit or the unit itself that was used in the given, which is centimeter, and to put the exponent instead of using the cc. Cc was indicated that to show what is the cubic, okay? But in terms of different kind of units already, for example, meters or inches, it will be different already. So better to use the unit and the exponent. Okay? Alright. So let's deal with this one. Okay. So when we have this formula, what's your formula? Length times width times height. Okay? So basically what we used to do is to find the length. What is your length? Oh, it was stated that is 4 centimeters. This is your length, and your width is 8 centimeter, and your height is 15. So let's just say, okay, let's just say that in terms of getting what is the length, what is the width, what is the height, it's up to you already whether what is the length, what is the width, and what is the height, as long as you are basing to the three types of edges that you have. For example, this is the first edge, this is the second edge, and this is the third edge. How can we differentiate? Or let's have an example, no? So if this is, for example, let's use blue. If this edge is your height, or what are the heights? These are the heights. So all blues are your heights given. So you need to put that one. How about for the width? This is the width. All yellows are I'm sorry. All yellows are width. So the width are yellows. And what is your length? I'm just referring, this is your length. It's up to you already. As long as you have the three types of edges. Okay? And when you multiply them, we come up in one final answer. Okay? Because whether you choose this side as to be as the length, and this side as to be the width, as to be the height, as this one as this edge, we will end up in one answer. Are we clear? Okay po? So, when we have the 4 centimeter, 8 centimeter, and 15 centimeter, and when we multiply them all, no, what we could have is when you multiply 4 times 8, 4 times 8 is 32. And when you multiply it by 15, that's the time that we could get the 480. No? And don't forget the unit, which is centimeter, and the cube. Why is it cube? Because we have the three-dimensional. No? And when we are referring for the volume, we are referring for how many cubes can we fit in, or the capacity that we could find in a specific shape. Alright? So, once again, just to review, no, when we are referring to the volume, volume is the amount of space or the capacity, no, that something takes up. Alright? So, again, this is the formula of the volume for the cube. And for that rectangular prism, this is the formula. Okay po? So, this is the formula for solid objects with straight edges only. Again, straight edges only. No? That's why we have this cube and rectangular prism. Are we clear? Clear po? Alright. So, in terms of, let's just say, for the last example, no, let's just say you have this rectangular prism. For example, this is a rectangular prism. Okay, this is a rectangular prism. Now, your rectangular prism contained of three edges. You have a length. No? You have a length, let's just say you have 12 meters. And you have a height of 8 meters. And you don't have the width. This is your length, this is your width, and this is your height. So in terms of your formula, this is a new thing, I know. For those who are still watching until this time, no, we already have this an hour when we are discussing this one. For those who are still watching this one, you're very lucky. Alright, so when we have the formula of rectangular prism, no, what is the formula? We have the length times width times height. So as you are the very lucky one, okay, the technique when your width is missing, okay, for example, let's just say, when you have a missing part, what you need to do is to find it first from what is the volume. Let's just say you have a volume of 384. For For example, these are the given. The volume, let's just write it already, no? Let's write it already. For example, this shape has the volume of, or V, no? Of 384 meter, cubic meter. Ayan. Okay? Now, when we have this one already, and you have this given, what would be your height? I'm sorry, your width is missing. What would you do? First things first, what is my instruction? You need to put your given. Or let's just say what you've done is to put your formula. Okay, this is your formula. Done. Okay, given. That's your formula. Now, once you're done with your formula, you put your given. Or what are your given? V is equal to 384. Okay? Oh, that's the one, ha? 384. Now, what's the next given? You have length. Length is, what's your length? 12 meters, correct? What is your width? Width is missing. Height. Height is, what's your height? Height is 8 meters. Okay? So in that case, the next step is to substitute the values of the given to your formula. So how are you going to substitute? What's the value of your V? The value is 384 is equal to length times width times height. So length, what is your length? Your length is 12 times width. What is your width? Oh, you cannot just simply put the question mark. What you're going to do is to put W or width because you don't know what is the value of your width. You just uh, uh, put W as it is. Okay po? You're going to leave it as whatever it is. Now, the last part is the height. And what's the value of your height? The value of your height is simple as 8. Correct. Now, in that case, what are we going to do? Because we are finding not for the volume because volume is given already. In this case, in this problem, we are trying to find the width. So in that case, what I've taught you last time, no, we have uh, a discussion, we have a topic with regards to this format. If you will remember in the algebra, correct? When there is missing, what you need to do is to find what is missing. What's the missing one? That is the W, correct? Where is the W placed in the equation? From the word equation, we have the equal sign that represents that there are two values that are equal to each other. So therefore, we have the left side and the right side. So where is the W resides or placed? It's in the right side, correct? So what you're going to do is to uh, transfer all the values of your right side going to the left side. And you're going to leave W as it is where it is placed. Okay po? So what are the values that contains in the right side aside from W? So those are the 12 and 8. So in terms of algebra, no, what we tend to do is if it's addition, no, I'm going to give you a recall in terms of this kind of situation. What we tend to do, correct, is that, for example, you have 42 is equal to, let's just say, 1, let's just say, the 2 plus W. For example, 2 plus W. you're finding for the W, what we tend to do is to subtract 2 in each side. You have left side and right side, correct? Because you want to cancel out. You want to leave W as a lone value or single value in the right side. The value on your right side should be W only. Okay? Because on your right side, you have 2 plus W. You need to put all the values with W going to your left side. So how are you going to cancel? You need to subtract it, correct? Why did you subtract it? Why? Why do you think? Because we saw that the operation on your right side was addition. So in order for us to cancel the values along with your W is to subtract it because the operation was addition. So in order for us to subtract it, now you can see that 2 minus 2 is simple as 0. It will turn out as 0 plus W, correct? So it will turn out as simple as W. W is equal to 42 minus 2. Why did we minus also the left side? Oh, from the equation, no? From the equation, when you have an equation or equal sign, it represents that there are two values that are equal to each other. That's why whatever you do in your right side, you do in your left side. Whatever you do in your left side, you do in your right side. Knowing that we subtract 2 in your right side, what you will be doing is to subtract 2 to your left side as well. So in this case, we will be subtracting 2 to your 42. And that's why we can see that 42 minus 2 is 40. And now we know that your W has the value of 40. Now, in this case, what we did is to deal in the two fundamental operations, correct? So that is this addition and subtraction. So once we saw that the operation that was used in your equation was addition, we know that the opposite operation of addition is subtraction. So therefore, once we are dealing in multiplication, in order for us to cancel the opposite operation of it, in order for us to cancel, is to divide it. So let's go back to the given that we have. So in order for us to cancel these two, no, in order for us to cancel these two, before you cancel these two, what you need to do first is to fix this one in arrangement. So how do we arrange this one? 384 is equal to W times 12 times 8. Once you arrange that one, you could multiply this first, 12 times 8. And what is 12 times 8? 12 times 8 is what? 96. Oh, let's have a 12 times 8. That is simple as 8 times 2, that is 16. Carry 1. 8 times 1, that's 8. Plus 1, that is 9. Oh, that's why it's 96. No? So it is 96. Now, we could say that W times 96. So, in this way, we could now cancel it much easier. If in a format of that, if it's 384, oh, let's write 384 is equal to W times 96. Again, from the fundamental operations, what are those fundamental operations? We have addition, subtraction, multiplication, and division, correct? So, when we use addition, the opposite operation is subtraction. When we use multiplication, the opposite operation is division. So, where is your W located? From your left side or right side? Of course, in your right side. And what was the operation that you could found between the two values, or the W and the 96? What was the operation? It is multiplication, correct? And think of it, in order for you to cancel the 96 in that right side, transfer in the left side, no? How do we cancel it? By using the opposite operation. So how? So from your W multiplied by 96, 96 divided by 96. You should divide it by itself in order for you, no? In order for you to cancel it. Okay? So once you do it in your right side, once again, no, you should be equal. So 384 divided by 96. So 96 divided by 96, that is simple as 1. So W times 1. And we know that W times 1 is simple as W. Correct? W. Alright. So, we could say that when we divide these two values, 384 divided by 96. Oh, 384 divided by 96. Do you want manual? Do you want calculator? So, if we're going to divide that one, 384 divided by 96, we could end up with 4. Or how? If you want to know, 384 divided by 96. You cannot divide that one into by 3, even by 8. If you will be trying that one into 3-digit number for 96 times 4, no? 6 times 4, that is 24. 32. 4 times 9, that is 36. Plus 2, 38. So, it is 384. So, it is correct. So, the final value when you divide 384 divided by 96, the answer is 4. And now, we know, no? We know that the value of your width is 4. The value of your width is 4. For what? Is this the final answer? For what? What kind of 4? 4 meters. Because the other units of your given is in meters. The units of your other givens was meters. Okay? So that's the process how to identify the other parts of your volume. Alright? So in that case, I hope that you learned something for this day. I know it was a long day, no? So if you like this video and if you learned so much, you may hit that like button. And if you want to subscribe, you can now follow me, no? And to press that subscribe button. All right. So with that case, if you have some concerns, if you have questions, you can comment that one so that I could answer your queries. Or if ever you have some uh suggestion, you can leave it also in the comment section. All right, so with that case, I will be closing this one already, and I hope that you will be staying in tune for the next video that I will be uploading. See you on the next video. Thank you, and God bless. Bye.